Hey everyone, this is number 6 from the 2019 FRQ. It says functions f, g, and h are twice differentiable functions. G of 2 equals h of 2 equals 4. The line given is tangent to both the graph of g at 2 and the graph of h at 2. Part C says that the function h satisfies h of x equals x squared minus 4 over 1 minus f of x cubed for x not equal to 2. It is known that the limit as x goes to 2 of h of x can be evaluated using L'Hopital's rule. Use the limit as x goes to 2 of h of x to find f of 2 and f prime of 2 and to show the work that leads to your answers. So first, I want to look at this limit as x goes to 2 of h of x. So the limit as x goes to 2 of h of x, we actually know that that is going to be 4. And the reason we know that is because not only were we given that piece of information, that at x equals 2, that the output is 4. The two-sided limit being 4 is not necessarily guaranteed, except that it says h is differentiable. And differentiable implies continuity. And so if you have a continuous function, that means that the output is also going to be the two-sided limit at that x value. And you could see that in the visual. Because h is continuous, the output at 2 is 4, but also the limit as you come from the left towards 2 and the right towards 2, you're approaching a y value of 4 as well. So the rubric has a statement there that says, because h is differentiable, it is therefore continuous, and that is what makes us allowed to make that leap, that the limit is going to be the same as the output there. So then we are going to use that idea. The first thing, do that later. The first thing that we're going to figure out is f of 2. And I'm going to start with the fact that they told me I could use L'Hopital's rule. Okay, so the limit as x goes to 2 of h of x. H of x is the same as x squared minus 4 over 1 minus f of x cubed. The fact that I am allowed to use L'Hopital's rule on this function, that means that when I plugged in 2 to the top, think about what I would get. I would get 2 squared minus 4, which is 0. And you can pause if you want to. The reason we're allowed to use L'Hopital's rule is because if I plug in 2 to the bottom, think about what I'm supposed to get there. If I plug in 2 to the bottom, I must also get 0, because getting that 0 over 0, that indeterminate form, that's what allows you to use L'Hopital's rule. So that is going to give us an equation to solve. The idea that I know if I plug in 2 to the top, I get 0. If I plug in 2 to the bottom, I also get 0, and that's why I can use L'Hopital's rule. That's going to give us an equation right here to solve. 1 minus f of 2 to the third, I know that that denominator should be 0, and I'm going to just solve that equation. So I get negative f of 2 cubed is negative 1. I can divide by negative 1, and I get f of 2 to the third is 1. And then if I do the cube root on both sides, I get that f of 2 is equal to 1. Okay, and then, so that's the first thing that they wanted me to find, f of 2. And then we're going to also do f prime of 2. Then we're going to go back to that limit and use L'Hopital's rule. And I forgot to say one thing. I wanted to say that I very deliberately did not write it as a fraction and do my 0 over 0 in that format because a quotient cannot be equal to 0 over 0. So the AP test really wants you to write them separately. You can see that I worked with the numerator here to say that the numerator is 0, and I worked with the denominator here to say the denominator is 0, and that's what allows me to talk about this instead of saying the quotient is equal to 0 over 0. Just look at them separately. All right, so then we're going to go back to our limit statement. So our limit statement was limit as x goes to 2 of that h of x function can be solved using L'Hopital's rule, is what the question said. So I'm going to do L'Hopital's rule now. And L'Hopital's rule is when you take the derivative of the top, which is 2x, and you take the derivative of the bottom. So the derivative of 1 is 0, but then you would bring down the 3, and you have that negative sign that's sitting there. It's going to be negative 3 f of x being squared, and then the derivative of the inside is f prime of x. So this is the chain rule. The 3 moves down, the inside stays, 3 becomes a 2, and the derivative of the inside is f prime of x. If I go back to the beginning, I knew that that limit, that two-sided limit, was going to be 4, right? Because remember, the output was 4 and it's continuous, so I knew that I would have that limit would be equal to 4. So I'm going to put that right here, equals 4. Then I'm going to go ahead and plug in my 2. So that's something that we do when we are finding limits, is plug in the numbers. So 2 times 2, negative 3, f of 2 being squared times f prime of 2. And the fact that I know that this is equal to 4 is going to allow me to solve this. So the top is 4. On the bottom, I have negative 3. Now f of 2, that is what I found in the previous part. F of 2, I figured out that that was equal to 1. So I'm going to replace that with a 1 times f prime of 2 equals 4. 1 squared is 1. So I have 4 over negative 3 times f prime of 2. Okay, and then you are trying to solve this for f prime of 2. So maybe what I would do, I'm going to move this equal sign a little bit. Maybe I would multiply by f prime of 2 on both sides. And that brings that out of the denominator and into a numerator. So 4 over negative 3, 4 times f prime of 2. And then I'm going to divide by 4. You could also write it as times 1 over 4. Right? Divide by 4 is the same as multiplying by 1 over 4. So that cancels and those cancel. And I have 1 over negative 3 is f prime of 2. Okay, and then I just want to say, if you hate that times 1 over 4, you have 4 over negative 3 equals 4 times f prime of 2. If you did divided by 4, that's fine, because you know that this is division, and 4 over negative 3 divided by 4 is the same thing as multiplying by the reciprocal, right? So you still get negative 1/3, or 1 over negative 3. The rubric has a lot of detail, and I did not have all of this in my answer. So I'll talk about that at the end if you want to listen. But the first point was knowing that that limit was going to be 4, and that's what we talked about in the beginning, that the output was 4, but also because it's differentiable and continuous, that the limit is also going to be 4. So that's how they awarded the first point. The second point was figuring out that f of 2 is equal to 1. The third point was using L'Hopital's rule So I would say that is this step, that you were able to take the derivative of the top and the derivative of the bottom. Remember, that's not the quotient rule. The quotient rule is low d high minus high d low over the square of what's below, right? L'Hopital's rule, you're just taking the derivative of the top and the derivative of the bottom. So that was a point. And then the last one is if you were able to get that f prime of 2 is equal to negative 1/3. So I think if you are good with that, you could stop the video there. I'm going to just point out a little bit more of the nuance that they have in the rubric if there is anyone interested in listening to that. So I would say that we had the first sentence, right? We did that. Then they stated, this is them stating that the limit as x goes to 2 is h of x, and then they're just writing it with the formula. So I don't think that part is necessary. They're taking this statement right here and just filling in the formula. Then you can see that they looked at the top of the fraction and said it was 0, and the bottom of the fraction and said it was 0. And then for their answer, instead of concluding that f of 2 is 1, they kept it as a limit, and they said, okay, I know the limit as x goes to 2 of f of x is equal to 1, but then because f is differentiable, that was given in the original stem, f has to be continuous, so then that limit is going to be the same as the output. It's a lot like what we did at the beginning, kind of reverse order. They know that the limit as x goes to 2 is 1, but then once you bring in the differentiability and the continuity, then you would say that's also the output. I'm going to draw something like this. Because remember, knowing that the limit as x goes to 2 is 1, that's not the same as an output of 1 at x equals 2, because you could have an open circle there. So just because you know the limit as x goes to 2 is 1, it's not until you bring in the differentiability and continuity that has to be continuous. So then the output is also going to be 1. So they have that added step of logic there. Then they say f is twice differentiable. So that means that f prime is continuous and f prime is continuous. So then the limit as x goes to 2 of f prime equals f prime of 2, like that number exists. So because you have twice differentiability, f prime is continuous, and so you know that f prime of 2 exists, and then they use L'Hopital's rule to actually find it. So they're stating why it has to exist before they actually find it. I'm not sure if they would require all of those statements. Based on the rubric, it looks like they're just looking for those 4 things. So that's why I didn't mention all of them in my original solution, but that is an explanation of why they are there.